Today, we will explore one of the most exciting shifts in AI, moving from generative AI, which creates text, images, and insights, to agentic AI, where systems don't just generate, but they also reason, take actions, and collaborate with other tools or agents. This evolution marks a step towards autonomous intelligent systems that can work alongside us to solve complex real world problems.
If you're still using old Fang Prep guides, you're already losing ground. The rules have changed, and this free AI playbook shows you what's really being tested in modern Fang interviews. Insider strategies, hidden evaluation matrix, a 90-day mastery plan, the exact playbook successful candidates are using right now. Everyone's grabbing it. Don't be the one left behind. Link in description.
So imagine you set a goal to get weekly sales insights. Instead of manually pulling data, crunching numbers, and drafting slides, you let agents handle it. First, a data agent queries the sales database and pulls key metrics. Next, an analytics agent interprets the results, spot trends, highlight anomalies, and surface what matters the most. Finally, a writer agent takes those insights and turns them into a structured business report complete with recommendations. That's the power of agentic AI. Multiple specialized agents collaborating seamlessly to turn a raw data into actionable intelligence. And here's the agenda for today. We will start with evolution from generative AI and moving towards the agentic, and we'll see how simple prompt response model has hit a wall. Then we will dive into work, including memory, reasoning, and orchestration. And from there, we will explore how to design for autonomy so agents can operate safely and effectively. And I'll share insights from fan class engineers on how are they applying this in production. Finally, we will wrap this up with the live demo of multi-agent workflow in action, showing how agents plan, execute, and adapt and could even collaborate in real time. So, hello everyone, I am Prateek. I bring over 9 years of experience in distributed system, cloud engineering, and large-scale analytics. My core expertise is in PySpark and Azure, but what excites me most is combining that strong data engineering foundation with generative AI to build secure, scalable, and intelligent systems. At Microsoft, I have developed AI agents that not only optimize planning, but they also provide smart recommendations through a natural language interface. Now, this means instead of spending hours digging through dashboards, teams can just ask questions in plain English and get instant data driven answers. Along the way, I have earned certifications in like DP600, DP203, AZ900, and beyond the credentials, I have built hands-on solution in generative AI and autonomous agents. And I also enjoy mentoring others and leading teams through complex data and AI challenges. And I have been mentoring at Interview Kickstart into generative AI and building AI applications sections. Now, when we talk about AI in software and product design, there are two terms that often come up: generative AI and agentic AI. They sound familiar, but they represent very different capabilities. And understanding the difference between them helps us design smarter products. Now, let's break them down into three ways: what they do, how they interact, and how we think about them in product design. Now, generative AI is great at creating content, including text, code, designs, or summaries, when you give it a prompt. For example, GitHub Copilot suggests code is pure Gen AI. You type a comment and it gives you a code block. Agentic AI, on the other hand, is about code completion. It doesn't generate something, it takes step towards achieving an outcome. Think of like Microsoft 365 Copilot agents. They don't just draft an email for you. They can summarize entire threads, schedule follow-up meetings, and coordinate across apps to actually finish the task. So if Gen AI is like a really smart intern handling you drafts, Agentic AI is like a project manager who listens to the goal and then coordinates actions to get it done. And the second difference is how they interact. Generative AI usually works in a single turn. You ask for a summary or a SQL query and it gives you an answer. Done. Agentic AI works in loops. It plans, executes, checks the results, and adapts. For example, ChatGPT writing a blog post in one go is Gen AI. But imagine an AI tasked with reducing churn. It queries the CRM for at-risk customers, analyzes their activity, routes personalized outreach emails, and if the API fails or the data looks off, it retries and adjusts. That's the multi-step reasoning loop, not a single response. And this loop behavior is what makes agents so powerful. But it is also why they require more thoughtful design around safety, error handling, and guardrails. Finally, let's talk about design implication. Now, in software, Gen AI should be treated as an enhanced feature. It makes individual tasks smarter, like Figma generating icons or autocomplete suggesting SQL queries, but these are localized improvements. Agentic AI, by contrast, sits at the workflow layer. It doesn't just improve one feature, it orchestrates across multiple features and even multiple systems. Now, picture an agent that takes a design brief, generate mock-ups, gather user feedback from the surveys, and then iterates on the design automatically. Now, that's not just a feature, that's an intelligent workflow running on its own. So, when you are designing products, Gen AI is for better features, whereas Agentic AI is for the new autonomous workflows. Both are valuable in their place, but they play a very different roles. So, to recap, Generative AI creates content, Agentic AI completes codes. Generative AI is one shot, Agentic AI is multi step. Gen AI enhances features, and Agentic drives the workflows. So, as software engineers and product managers, the key is to design a smarter workflow. You have to choose whether your product needs a smarter feature or it needs a smarter workflow. You get that right, and you can unlock real value for your users. Generative AI has been revolutionary in how we generate content, whether it's drafting emails, writing code snippets, or summarizing documents. But when we start thinking about workflows instead of one-off outputs, static Gen AI pipelines, they hit a serious limit. Let's break that down, what those limits look like. Before that, let's acknowledge the state. Gen AI is accelerated producing content on demand. You give it a prompt and it can generate text, code, design, or summaries in seconds. For example, GitHub Copilot suggests a function as you type, or ChatGPT can generate a marketing paragraph instantly for you. But notice the pattern here. These are single turn interactions. You ask it, it answers. That's powerful, but that is also where the limitations begin. So let's talk about the first big limitation, which is memory. Gen AI doesn't naturally remember what happened yesterday or even in the last conversation unless you explicitly feed that context back in. Imagine working with an intern who's brilliant in the moment, but every day they walk in and they completely forget what happened the day before. You would have to keep re explaining the same background information over and over again. So, for example, if you are analyzing a sales trend over a quarter, static Gen AI pipeline can summarize a data set today. But tomorrow, if you ask it to compare the trends across weeks, it won't remember the data set unless you reload everything. That lack of continuity makes multi step reasoning analysis very frustrating. The second limitation is planning. Gen AI doesn't inherently break a goal into smaller steps. It's great at producing an output directly from a prompt, but it doesn't strategize. Think of asking it like, help me improve user retention. A Gen AI model might generate a nice list of suggestions like improving onboarding, sending reminders, but it won't actually design an experiment or even query your CRM or validate whether those ideas work or not. In other words, it's like the same intern giving you a long brainstorm list, but never returning or turning into a project plan with milestone dependencies and success metrics. The third limitation is tool use. Gen AI is confined to words and code. It doesn't naturally connect to APIs, databases, or external systems unless you build integrations around it. So let's say you ask it to find top churn customers and draft an outward email. A Gen AI model can draft those emails, but it can't directly pull the customer list from your CRM. It can't run queries or it can't even trigger an A/B test. It's like asking an intern to book a meeting. They will write you a perfect calendar invite, but they can't actually send it because they are not connected to your calendar system. You still have to do that manual step. So the analogy I like to use is like this. A is like a very smart intern, fast, capable, full of ideas, but forgets yesterday's work, doesn't plan projects, and can't run errands outside the office. And this is real consequences for workflows. For example, for a simple one-shot task like drafting an email or generating code, Gen AI is amazing. But for multi-step cross-system tasks like running experiments, analyzing data, and automating responses, it becomes a bottleneck. You end up with great drafts, but you still need humans or extra systems to stitch everything together. That are the limitations of generative AI pipelines. So that is why industry is now moving beyond static Gen AI pipelines towards agentic AI, which adds memory, planning, and tool use. The exact pieces that makes the workflow possible. Gen AI is the spark that creates content, but agents are what that turning that spark into real outcomes. And that is the shift we will explore next now. So let's start with the difference between traditional generative AI and agentic AI. Generative AI models like GPT are reactive. You give them a prompt and they give you an output. It's a single shot interaction. Great for things like drafting an email or summarizing a document, but that's where it ends. Agentic AI, on the other hand, is proactive. Instead of waiting for the prompt, it can take a goal, break it down into plan, and then execute actions or even call tools to get the results. Think of it less like an autocomplete, but more like a digital teammate that can operate with minimal oversight. So, when do you use AI? It shines in scenarios that needs planning and multi-step reasoning, or even tool use like chaining API calls, running queries, or coordinating tasks. It is also built for adoption, handling dynamic environments where conditions may change mid-process. So in short, if you just want text generation, you can use generative AI. But if you need adaptable autonomous workflows, that's when you move from generative AI to agentic AI. Okay, now let's break down what actually makes up an agent. The first component is the reasoning engine. Now, this is typically a large language model like GPT or Gemini, and this is the brain of the agent. It will interpret the user input, decide what are the next steps that are needed to be done, and orchestrate the plan to fulfill the request. The second component is tools. Now, you can think of tools as agents' hands. Tools let your agent go beyond the language. Things like calling APIs, running SQL queries, fetching data, triggering workflows in external systems. Agents typically connect to tools using function calling or protocols like MCP. And the third component is memory. Now, memory is what gives agents context and continuity. It allows the agents to remember what happened earlier in a session or even across the sessions. So it doesn't always start from zero each time. Memory can also be reflective, helping the agents improve its plan over time. But together, these three reasoning engine, tools, and memory turn an LLM into an agent that can not only think but can also act and learn. Now, let me walk you through how an agent works using the customer churn example. At the top, we start with a goal like reducing customer churn and proactively reaching out to at-risk customers. Next part is planning. Now, this is where agent figures out the steps. It needs to analyze the historical data, identify which customers are likely to churn, draft personalized retention email, etc. Now, the data step feeds into this plan. It will pull the customer usage patterns, support tickets, and billing history in this case. Then comes the app. Here, the agent is using connected tools, for example, like a churn prediction model or even an event generation system, and it might run the prediction or generate draft emails and even push them into the CRM. This is where the system integration comes in, connecting to your company's actual systems to execute the plan. After acting, the agent doesn't stop. It goes into reflect, reveal outcomes. It could include looking at things like products, like are the predictions accurate, are the emails well tailored. This reflection then goes back into the memory. So agent learns what works over time. And finally, it delivers a response, such as list of flagged customers with ready to send personalized emails. So instead of answering a query, agentic AI will continuously plan, act, reflect, and improve, making it ideal for complex workflows like churn management. Now, let us explore the key core capabilities of Agentic AI. There are four key capabilities that make Agentic AI truly powerful: autonomous decision making, chaining reasoning steps using tools and APIs, and integrating feedback loops. Now, together, these capabilities transform AI from a passive assistant into an active problem solver. So, autonomous decision making. First, let's look at traditional AI systems often wait for explicit instructions at every step. They are rule based and reactive. Agentic AI, on the other hand, makes choices independently. It doesn't just follow the rigid patterns. Instead, it will evaluate goal, interpret surrounding context, and look at the prior results before deciding on the next best action. So, for example, if the goal is to analyze a data set, the agent might first retrieve the data, then notice that it is incomplete. It might then decide to call an API for missing values, or it may even refine the previous answer before returning the result. This autonomy allows the AI to move faster and operate more efficiently, closer to how a human expert might take the initiative when solving a problem. The second capability is chaining reasoning steps, also known as multi-hop reasoning or chain of thought. Now, when faced with a complex problem, agentic AI doesn't try to just jump straight to the answer. Instead, it will break the task into smaller, more manageable subtasks, solve them step by step, and then combine the results. Think of how human plans. If I ask you to plan a trip, you wouldn't just do it in one step. You would first find tickets, then maybe book recommendation or accommodations, and then finally create an itinerary. Agentic AI follows a similar structured approach. This makes it much better at handling complicated domains like math, logical puzzle solving, or project planning, where reasoning across multiple steps is critical. And by chaining these steps together, AI not only reaches better answers, but it is also able to make the process more transparent and reliable. Next is using tools and APIs. This is where agentic AI really breaks free from being just a text generator. An agent can call external systems like databases, calculators, or APIs to extended capabilities. APIs essentially acts as a bridge that connect the AI to other services. For example, instead of simply describing today's stock prices, an agent could call a financial API to retrieve the live data. Or instead of estimating directions, it could call a mapping API to generate an actual route. Now, this makes the AI far more usable in a real world. It's not limited to the knowledge it already has, but it can take actions, fetch data, run code, and even interact with the environment to solve practical problems. Finally, let's talk about the integrating feedback loop. After an agent takes an action, it doesn't just stop. It evaluates the outcome, like was the action successful, did it produce the right result, if not, how can it improve? And this can involve the self-reflection, such as checking if the generated query is valid, or it can even use external signals like user corrections or system feedback. Now, through this cycle of perception, action, and reflection, the agent gradually improves its performance. It is very similar to reinforcement learning, where correct actions get reinforced and mistakes are penalized. The result is an AI system that doesn't just execute tasks blindly, but also the one that learns, adapts, and grows more effectively over time. Okay, now let's start with why orchestration is important. Now, a single agent is powerful, but it is also limited. It usually handles one task at a time and doesn't scale well to more complex workflows. Whereas in real world, tasks almost always require multiple steps, tools, or even multiple specialized agents. Think about building a BI report or automating a support workflow or even managing a deployment. These are not single shot problems. And that is where the orchestration comes in. Orchestration ensures three different things. First, coordination of actions. Agents know what comes next and who handles it. Second, error handling and retries. So if something fails, the workflow doesn't stop, it adapts. And third is adaptive workflow. Agents can respond to changing conditions and still move towards the goal. So orchestration will turn this autonomy into a scalable, reliable work. So what exactly is this orchestration? At its core, it's a structured management of how agents, tools, and workflows interact with each other to achieve a goal. It's what ensures the tasks happen in the right order, with the right context, and with a feedback loop that allows the agent to collaborate and improve. So, an easy analogy for an orchestrator is like a conductor in an orchestra. So, each instrument for us, here, planner, coder, and executor, is capable on its own. But without a conductor, you don't get harmony, you would get noise. So, orchestration keeps those different parts working in sync to produce a coherent outcome. Now, how do we actually orchestrate agent workflows? We use frameworks like Autogen, LangChain, Semantic Kernel, Crew AI, and Haystack. Now, these provide the building blocks to set up agents, define their roles, and connect them with tools and data sources. In terms of approaches, there are several common patterns. First is human in the loop checkpoints, where humans can review or approve outputs at critical steps. Then we have workflow graphs or DAGs, which is similar to Airflow or Prefect, where we're defining the dependency between agents and their execution order. Next is multi-agent collaboration, where we assign roles like planner, coder, critic, and they work together among each other autonomously. And lastly, we have reflection loops. So where agents review their own or each other's work to catch errors and even improve the results before the final delivery. So let's take it with an example of our business intelligence report. How do we generate a BI report? Okay. So the planner agent will start by breaking down the goal into steps. So things like querying the data, analyzing the data, and creating a visualization and summarizing the findings. Then the coder agent will write the SQL or the Python needed. And then the executor agent will run the code and check if the results make sense. And finally, the critic agents will review the final report, checking for quality and clarity. And behind all of this is the orchestrator, the conductor, making sure each handoff happens smoothly, retrying if something fails, or pulling the pieces together in one coherent output. And this is the difference between an isolated agent that can just write SQL and a coordinated agentic system that can deliver a polished end-to-end BI report with minimal human oversight. So to sum it up for now, orchestration is what elevates agents from being interesting point-in-time solutions to scalable adaptive workflows. It's how you get from a single assistant to a system of collaborating specialists. And for us as an engineers and PMs, understanding this orchestration is the key to designing real-world applications that are reliable, flexible, and production ready. So, Now let's introduce Autogen, which is a Microsoft research open source framework for orchestrating intelligent multi-agent systems. Whether you are writing code or strategizing product workflows, Autogen empowers you to build, coordinate, and scale autonomous agentic applications with flexibility and observability. So Autogen is an open source programming framework designed to build multi-agent where agents converse, collaborate, and solve tasks together. It was redesigned recently in version 0.4 to use asynchronous event-driven architecture, which enables more dynamic workflows with improved observability and robust scalability. So let's start with its asynchronous event-driven architecture. So agents communicate using these asynchronous messages and they support both request response and event driven interactions. Now, this is ideal for complex long running workflows. Next, it's modular and extensible design. We can plug in custom agents, tools, memory, stores, and models, whether we are building in Python or .NET, and build proactive persistent agents. Then it has a layered API design. First up is a core API. So for low level orchestration, for things like message passing and distributed runtime. Then it has Agent Chat API, which is a high level opinionated interface for rapid prototyping of multi agent conversational patterns. And then it has Extensions API, which allows seamless integration with clients like OpenAI or Azure, tools, and code execution environments. So for PMs and virtually oriented software engineering teams, Autogen Studio is a game changer. It's a low-code drag and drop UI for designing, testing, and iterating multi-agent workflows without ever writing the code. This dramatically lowers the barrier for prototyping agent-based logic, and it allows product and engineering teams to collaborate more efficiently. So in summary, Autogen is a powerful framework for building collaborating autonomous AI workflows, combining modular, event-driven agents, rich observability, code-free design in Studio, and seamless integration with tools and memory. So for both engineers and product manager, it provides the infrastructure to architect, to prototype, and scale intelligent multi-agent systems efficiently. And now let's look at some of the core challenges for designing for autonomy. AI systems today, they face three big challenges. One is making decisions, second is adapting, and third is scaling. So first, they must make decisions. That means processing signals from many different sources, including data, APIs, and even other agents, and choosing the right mixed action. And those choices need to be accurate and trustworthy. Second, they must adapt. The world isn't static. Data shifts, user needs change, and even the environments around them. An effective AI system can't just give the same answers forever. It needs feedback loops and reflection to continuously improve. And third, they must scale. So a prototype might work on a single user request, but in production, these systems often face millions of events per second, or they could even be thousands of agents working together. Scalability is what keeps the performance strong as the demand grows. So the core challenge is balancing all these three: decision making, adaptability, and scalability in one architecture. And that's where the event driven design and agent pattern works become more powerful. Now let's talk about some of the agent design patterns. Let's start with a reflection pattern. This is about helping agents analyze and improve their own performance. So instead of just producing an output and moving on, the agent pauses and checks its own work. So this happens through a self-evaluation. The agent will generate a response like this. It will generate a response and then it will review it. So it will check whether the response is accurate, can it be improved, and if it can be, it will refine the answer before taking the action or even presenting the final output. So this goes in a loop. It will produce a response, it will evaluate the response, and if the response is not good, it will again generate a response and then goes on this cycle. But if the response is good enough and it leaves no update, it will go back to final response. So let's take this example of a dialogue responses. So here we can see it ensures that the conversation is accurate and coherent by doing the self-reflection. And in the next example of code optimization, an agent is improving its generated code through multiple refinement routes. So reflection allows you to produce higher quality and more reliable outputs by building improvements directly into the workflows. Next up is the planning pattern, which is about breaking complex tasks into smaller manageable steps. So instead of solving everything at once, the agent acts as the controller that organizes the workflow. Okay, so here how it works. LLM receives the overall task. It will decompose the task into smaller subtasks. And for each of the subtasks, it will then choose a specific model or a method that is best suited for the task. And those subtasks are then executed independently of each other, and the results are returned to the control. And finally, the controller will integrate everything back into a coherent response. Now, this approach is powerful for multi-step problems because it ensures that the system will tackle the complexity piece by piece rather than overwhelming single model. And next, we have a tool use part. This is what extends an agent's capability by letting it call external tools. So instead of relying on its own model, the agent can bring in outside capabilities, things like databases, calling APIs, or even using calculators. Now, this is especially important when we need strict accuracy, things like mathematical calculations or retrieving exact values from a database. A language model might alone make an approximation, but the tool used ensures the correctness of the response. So, in this case, the LLM is given a description of all the available tools. Okay, so their purpose and required parameters, etc. And based on that task, the model chooses the right tool. It will generate a function call string for that tool, and then the system will execute the function and return the result. And the agent integrates the tool's output back into the final response. So it will use a tool, it will call the tool will produce an output, and that output goes into the response, and it goes into this cycle until the final response is produced. Now, in practice, this pattern allows the agent to retrieve data, even automate processes, or execute deterministic workflows outside the AI. So the essence of tool use pattern is that it makes agent more capable, accurate, and reliable by seamlessly integrating external systems into their brief. And when tasks get too big for one agent, we need new patterns. The first one is a multi-agent collaboration. So imagine a team where each agent is an expert. One will handle the retrieval, another doing the analysis, and another communication. By breaking down tasks and coordination, they can take the problem far too complex for one agent. Then we have a mixture of agents. So instead of many individual agents, this pattern builds a framework of expert submodels. So each incoming request is routed to the most relevant expert so that the system always uses the right tool for the job. And the third is agentic AI, where unlike traditional retrievals, these agents actively decide what information they need and then how to refine their queries in real time. Now, this makes them highly effective for workflows that need flexibility and adaptability. So, across these patterns, collaboration, mixtures, and agentic retrieval, the theme is same. Agent is working smarter, not harder, by sharing, specializing, and adapting to the task at hand. Now, let's talk about how do we scale these AI systems. So, instead of relying on direct synchronous calls where one component waits for another, these systems use event buses. So that means when an event occurs, like new data arriving or an agent completing a task, it gets broadcast into the system. So now other agents can pick it up and respond immediately. This ensures that the system remains responsive and fluid, even under heavy workload, because no agent is blocking other agents. And this kind of system is already inbuilt in AutoGen. Then, for agents to make good decisions and collaborate effectively, they need access to a common rich set of information. And shared context provides that. It ensures that each agent isn't working in isolation, but they can see relevant data, updates, or outcomes produced by other agents. This shared knowledge base helps agents reason better, coordinate their actions, and avoid duplication. Again, this thing is inbuilt in the AutoGen where you put multiple agents in a team and they can have a asynchronous communication with the shared context. Then we have autonomy and independence. Each agent should be able to function independently. Think of them like a specialized worker. One might retrieve data, another might analyze, another might act. They don't need to know about each other, like how they are working internally. But instead, they just need to contribute their piece to the overall workflow. This modularity makes the system far more resilient. So if one agent fails or changes, the rest can continue operating. And this kind of system is already inbuilt again in Auto. And then horizontal scaling. So as the demand grow, you shouldn't have to redesign the system. With an event-driven backbone, you can simply add more agents or consumers to handle the extra workload. Now, this is known as horizontal scaling, and it's what makes this agent architectures to support everything from a small prototype to an enterprise-grade deployment handling millions of events. Together, these four principles, which is asynchronous communication, shared context, autonomy with independence, and horizontal scaling, they form the backbone of how to design the AI systems that are not only effective in making decisions, but are also adaptable and scalable in real world. And all of this is inbuilt into the AutoGen, where we will see shortly in a live demo how it functions and how it is able to do the asynchronous communication among the agents, how all of them have a shared context, and they can autonomously and independently execute their own tasks. And we can even scale the entire workload just by adding more agents. So, Now for the part. In this, at Fang Plus companies, we are already seeing agentic AI move beyond experimentation and into actual product design, operations, and customer experience. Now let's look at this from both software engineering perspective and PM perspectives. So first up, a software engineer perspective. Design for observability. Engineers are treating multi-agent systems like distributed microservices. So with logging, tracing, and monitoring across agents. Now this is critical for debugging complex agent interactions and ensuring reliability. Next, keep human in the loop. So for safety critical or compliance heavy domains like finance or healthcare, engineers are building approval checkpoints so agents don't just make irrelevant decisions without human validation. Next, this is also very important where we sandbox the external tool usage. So now we allow agents to invoke APIs, databases, or even third-party tools. Now these engineers basically they run these in a sandbox environment. So a misstep like a bad SQL query doesn't cascade into a system-wide failure. Next, teams are learning on orchestration frameworks like Autogen, LangChain, Haystack to compose workflows as modular blocks. This composability lets engineers swap out the models, tools, or agents without breaking the entire workflow. And finally, securing agent to agent communication is again critical. The SWE teams enforce strict access controls and permissions so that agent can only call the API that is authorized to use. Now let's look it up from the PM perspective. On the PM side, the focus is on shaping the agentic workflows that directly impact the customers. It's about mapping user journeys. So PMs design end-to-end flows where agent supports the consumer experience or the customer experience like automated support triage or personalized product recommendations, etc. Now, after doing that, they will define each agent's role. Which agent is a planner, which agent is a critic, which is a executing, and ensuring clear responsibilities across the workflows. And then we have balancing the autonomy with control. PMs decide where the agents can act independently versus the human checkpoints which are required, striking the balance between efficiency and safety. And then they are also driving the cross-functional collaborations. So agentic system touch engineering, UX, and compliance. PMs coordinate across these domains to align workflows with both businesses and regulatory needs. And then we have metrics and iterations. So PMs, they are defining key metrics like customer satisfaction, efficiency gains, error reduction, and then they are refining these agentic workflows iteratively based on this measurable impact. So these thankless teams, engineers are ensuring that the agentic systems are observable, they are safe, they are modular, and they are secured. While PMs are shaping the workflows that maximize the customer value and the business alignment. And together, that's how agentic AI is moving from research into real world product and operations at scale.
If you like this video, you will love what I have to say next. The 14-week Agentic AI program at Interview Kickstart helps engineers build real, career-ready skills. You'll work on 2 live projects with FANG instructors and leave with portfolio work that actually makes a difference in hiring. Over 20,000 tech professionals have already trained with Interview Kickstart, with many moving into roles paying $300,000 plus. Want to learn more? Join the free upcoming webinar, ask questions, meet the instructors, and see if it's a fit. Not ready yet? No problem. Start with the AI agent building videos here on the YouTube channel. We recommend this one. Either way, the key is to just get started.